Bernoulli's equation essentially saying that, okay, along the streamline, no matter what the streamline looks like, the pressure plus half of rho times u squared is a constant, right, along the streamline. What it essentially says that is that the derivative along the streamline is 0. So essentially, if you, well, this I should actually write it down as not just the u squared, but in this two-dimensional world, is half of rho u squared plus half of rho v squared, right, is constant. Okay, what it is essentially saying is that along the streamline, this quantity has 0 derivative. So mathematically, how do you write it? It's the directional derivative, okay, of this whole thing, p plus half of rho u squared plus half of rho v squared is equal to 0. Okay, if you have directional derivative is equal to 0 along the directional derivative along the streamline is equal to 0, then that quantity is constant along the streamline, right? Okay, Bernoulli's principle, of course, it holds in a steady inviscid flow. So we can only derive it for steady inviscid flow. So this is equal to 0, and let's actually see what that means. Okay, what it means is that v dot grad of p, that's the first term, plus rho is going to be over here for the second term, rho times v dot grad of u squared plus rho times v dot grad of v squared, okay, is equal to 0. Now, it's a little bit hard to see this in general, but like let's actually look at, let's actually rotate the frame of reference to a single point where the x direction is actually aligned with the flow, right? So that's where the physics of this equation, it becomes obvious. So at that point, the directional derivative is actually just the u times d dx, right? And the plus this rho u times d dx of u squared plus rho u times d dx of v squared is equal to 0. Okay, of course, this case you can cancel out all these u's, and what we see is the following. So what we see is rho, okay, times u. Oh, sorry, I think I forgot a half over here and half over here. So the derivative of u squared is 2 times u, 2u times derivative of u, right? So that cancels with the half over here. So rho u times du dx plus here rho v times dv dx is equal to 0. And because we have rotated the frame so that the velocity is aligned with the x direction, so v is actually equal to 0. I think I forgot d dx of p plus this. So the third term becomes 0. So what we have is essentially the x derivative of p plus rho u times du dx, right? Which is, in this case, the directional derivative of the x momentum is equal to 0. So Bernoulli's equation is actually just the momentum conservation in the direction of the streamline. Okay, so that's what Bernoulli's equation is about. It's actually an integral form of our differential form of momentum conservation, but integrating not in just a single direction, but integrating along a streamline. That's what Bernoulli's equation is about.